Hi, as promised I will do this additional video where I show the flaws of this mechanical design of my MIDI pedals. Yeah, I started to build them right away without big planning, and yeah, of course there are some flaws. To prevent you from doing the same mistakes as I will show what you could improve on the mechanical design of this device. Number one topic, what I don't like on this device is the noise. It's way too noisy. So the pedals, they make some bouncing noises, and yeah, I will go in detail why is that so and what you could make different. Of course you can always turn the volume up to and ignore the noises, but when you're playing like in the evening and you living in a flat like me, the neighbors will kill you. So let's take a look where we could limit the noise of the pedals. One of the flaws which creates the noise of the pedals are the hinges. They are way too wiggly. I paid like €1.30 per hinge. They're the most cheap ones that I could find in the hardware store, but yeah, it sums up when you're building the device with this is 19 pedals, so it's about almost €30 just for the hinges, which at the end are really bad, and yeah, it's wiggly, and the whole pedal is kind of wiggly because of them. I tried to yeah, contract them with some pliers that helped a bit, but I will definitively go for another design right now. What I will do is just take one thick rod and put it through all pedals, and that's all. Maybe using some ball bearings additionally from old roller blades, or just buy new ones. They're not so expensive because they're quite common, and yeah, that would be it. So the pedals wouldn't wiggle that much, creating less noise on this. So you can see some of them are wiggly, some are not, because yeah, I have some the spaces here, they're not evenly distributed here. So this is here yeah, spot on or even less. I have some friction here on this pedal. You can see, you can hear the friction sound, but some of them there's too much space. Yeah, I would do something different on holding them in place, like yeah, like some felt or something that just is smooth and holds it in place. So yeah, this is the first point that creates really much noise on this device. And yeah, next thing, let me turn this up. Next thing, yeah, I'm using the springs, and they are way too strong. They are yeah, overpowered for these pedals. The pedals have been longer at the beginning. I cut them to this length because yeah, the long pedals are inconvenient. You don't need this at home, at least. You can use yeah, this shorter pedal design, or even shorter than that. With your feet, so you have enough precision to handle even smaller pedals. And yeah, there could have fit even, yeah, 2 octaves or even like 3 here. Maybe not 3, but complete 2 octaves with yeah, 24 keys. So this maybe would be better. And yeah, the lighter the pedals, the lighter the pedals, the less inertia they have. So they don't bounce that much. So this is the next thing. I even added here some felt thingies on the top and the bottom. You can see. So there is some felt, but when I release the pedal like this, the noise is really loud. So this is really not that good. The next time I will build a device like this, I will make the pedals way lighter and maybe a bit thinner. So this is an overkill. I will guess 2 centimeters is enough. When I press the pedal completely down, the spring is completely contracted and makes this metallic noise. So this is one of the most noisy things on this device. I just made a mold out of gypsum, so I just designed a stopper with this conic tip, which is has some kind of attenuation. And this was because I wanted to it's still possible. I wanted to do some polyphonic aftertouch. So when I press down the pedal, it will be stopped like this, but I still have some possibilities to apply more more force to the pedal, and it will contract even more. So since the sensors don't work linear, because the closer the magnets are, the bigger the change of the magnetic field. So you have even more resolution on the last millimeters. So this works quite well. I wouldn't change the design of how the Hall effect sensors are placed, because for aftertouch it's necessary that the sensors are getting close to the magnets over here. I can show it. So so this design is optimal. As you can see, the magnets are stopping like 1 millimeter or almost 1 millimeter from the sensor, and you have a note on like here, and if the stopper would be in place, I can just show it. Okay, so I have placed the stopper here, and that was the initial plan, that the stopper stops it. It even works. So this is a good design, and it stops right here, and I can apply more force, and this would be enough to implement this aftertouch. So, but you could still, if you are very emotional, you could still create the noise. So maybe the stopper, because of the shrinking, the stopper is too short. I just stopped doing this. I could go on with this solution, but I leave it as it is right now. And because I thought, okay, there are so many flaws or so many things that I would do different way, that it makes no sense to put more effort in this first version of this device. I left it like this, and it's good enough for now. Of course you could get used to it and just play. Yeah, but okay, this really sucks. This bouncing noise and with this hinge here. So this is a really, I don't like the hinges. So this is the worst decision I made, to put in the hinges, because when they bounce, even the hinges are wiggling and creating this noise. So this is what I don't like on the device. So, but all in all, I am happy with the outcome. I hope this hints helps you to do less mistakes on your first design, and you might also take a look at the different designs that are around and the internet. So I don't claim that this is the best one. It's really not. So yeah, but I came up with this, and I learned my lessons, and I think I might build another one, but I have a really huge stack of different projects that I would like to do first, and it's sufficiently good. So I hope you liked the series so far, and I will do maybe some more theoretical part videos about how to send MIDI messages to the computer, and I think this is the most important part, and how you can use the Hall effect sensor, maybe more details than I did before, and that's all. Just tune in.